units for rate and rate constant. So what we're going to be doing is calculating alongside with the units for the two practice problems in the previous video for rate law and rate practice. Again, the videos are in the links in the description. Please have a look at those first prior to this video. Let's have a look at those two examples. We'll start with the first one here. In the last video, we did eventually find the rate law, which kind of just looks like that, but instead of here, we found the rate law as the concentration of A and the concentration of B, and then we had our exponents of M, and then we had the N. Okay, but again, in the last video, we did replace them. So with this A, we replaced it with the concentration over there, and then for B, we replaced it with this concentration over here, and then the M, we did find our exponent, which was found to be 2, and N was found to be the exponent of 1. Again, see the previous videos, those two videos, rate law and rate law practice questions, to understand what I'm talking about here. But we did find these exponents here on the side. We just implemented them into here, and then we eventually ended up using trial number 5, which is this one over here. We eventually went through these steps, and then we found K. We found K, our rate constant. Okay, so if those are our rate constant here, the units were not given. I wanted to go through those two videos with you without having an emphasis on the units, because for the sake of time in the videos and just to decrease the complexity, I'm going to be doing it in this video. So we have K. How did we get this K, and what are the proper units? Well, let's first start off with what we've written out here. We had 9.36 times 10 to the negative 9. And that M, that capital M over there, that's for molarity. Molarity is also known as moles per liter, right? So I'm just going to be putting 2 moles per liter, okay? And of course, this is over seconds, right? This is a rate, so we have to put over seconds. Oops. Over seconds, okay? You could put sec or you could just put s, doesn't matter. And then this is going to be equal to K, okay? We're just copying this one out. So we put K. And then we just multiply it by that one, okay? Now, in the previous step, okay, it came from this, and it came from this. So if I were to write it out in the previous step, it was 3 times 10 to the negative 3, so 3 times 10 to the negative 3, and then this was in moles per liter, right? So I'm just going to be putting moles per liter. And in terms of the exponent, we had 2, right? So I'll just put a small 2 up there, okay? We're just kind of copying this out. And then, but we're just putting the units now in. And then we just multiplied it by this one over here, which was BRB, 1 times 10 to the negative 3. And then this is also to the power of 1. This is also moles per liter, okay? So this is what we are given right now. We're just going to do it all without the actual values, and we're just going to focus on the units. So if that were the case, we're just going to only take this, find the units, and then pop it back into the K. So I'm just going to write it out as moles per liter over second, copy this K, and then we don't need to really worry about these values like I said, so we'll just do our moles per liter from this one multiplied by our moles per liter of this one. And then of course this mole and this mole has a particular exponent to write up there due to the exponent rule. Whenever you multiply them, you're going to add them. So this one here adds with that, and then of course for the bottom one too, this here adds with that exponent due to this multiplication. So with this whole thing over here, these two combined will become moles squared over liters squared. So let's write it out as such first. Illustrate it. Moles squared over liter squared. Now, in order to isolate for our K, the one that we got over here, you obviously have to divide it, right? Because right now it is multiplying moles squared over liter squared. What's the opposite of that? It is divide moles squared over liter squared. So we're just going to do that over here. So you cancel these out perfectly. Do it on the right side, you need to do it on the left side. This is what you end up getting. Now, this looks a little bit messy, so what I'm going to do is make this look very, very clean. So instead of having our divided S over here, I'm just going to put it on the side there. Okay, and same thing for this one. Instead of having it as a divide liters, I'm just going to put it here on the side. Okay, so I'll just show you what I mean by that. So this moles per liter, that stays as such. I'm just going to put the S here on the side as such, and then divided by the same concept. Okay, moles squared, and then the L squared, just going to be putting it on the side. So this is what our K is. Oops, our K is. So, and I'm just going to again make this even more simple. Okay, so how do I make this even more simple? Well, technically this here is divided over 1. So what I'm going to do is have this moles per liter over per second again. So I'm making it a little bit more complex, but I'm doing it for a reason. I'm dividing it by our moles squared per liter squared. Okay, and now I'm going to have my 1 here on the bottom, because technically this is over 1. Okay, this here is technically over 1 as well, but this already has 2 divided symbols, so I don't want to make it more complex, right? This is moles divided by liter, and then I have another divided by second. Okay, so this is already quite complex. This one here, there's 1 divided symbol, but there's not another divided symbol. So we can squeeze in another divided symbol so we can expand this out. So instead of having just moles squared over liter squared, I also added that second divided symbol over there. Okay, technically this is over 1 as well. I've just outlined it and laid it out this way. So now we have these. As such, they look quite similar. Okay, obviously this one's squared though, and then this is divided by a specific denominator, which is always going to be S, but this one we just added a new one, which is just divided by 1, so it's going to be scaffolded a little bit easier. So instead of this divided symbol here, we're just going to change it. This is obviously rudimentary easy work. We just change it into a multiplication. We just flip this, right? So this one goes on the bottom, so we get 1 over moles squared per liter squared. That's it. So of course this one can cancel out with this one because they're diagonally on the side the same whenever we have these 2 fractions. So this cancels out. That means this 2 becomes a 1, and this 2 also becomes a 1. So we ended up just getting 1 over S multiplied by 1 over mole per liter. This is going to be equal to K. Now, this 1 over S is also the same as S to the negative 1. This multiplication symbol here, we can just keep it as a dot. If you just don't even want to use a dot, you can just kind of get rid of it. I'm just going to put a dot though. And then this moles per liter is the same concept. If it's a 1 in the numerator, just change the whole thing to an exponent of negative 1. So we have moles, per liter. And of course, we're just going to put a negative 1 over there. Okay, if you want to make it even more simple, this moles per liter is also known as M, right? So I can just put over here on the side. This moles per liter over here is also known as M. So instead of having this one over here, I can just make 1 over M. Okay, it's the same thing. Now, if it's a 1 in the numerator, like I said, you just change it into a negative exponent. So I'll just have M to the negative 1. That's it. So this is going to equal your K. Your K can be represented as S to the negative 1 times M to the negative 1. We can just write this all the way back into our 1.04. So technically, maybe I'll just put here, therefore, K is equal to 1.04 S to the negative 1 M to the negative 1. That's how you solve this. Now let's have a look at this question. This was again another question that we looked at just without the units over here in the previous videos, rate law and rate practice. Have a look at those prior to this one. We had K and we have to find its unit. So let's take a little backtrack and see where we were. This 156, we used it for this one. Okay, we used trial number 3. So let's have a look at that. So we'll put 156 seconds. Okay, so the seconds, we'll abbreviate it as S, and it's going to be equal to our K, and this over here was our S2082 minus. Okay, so we're going to put our 0.01 that we got over there. As you can see, it's just mirrored over there. we found its exponent to be -1, so our exponent for our m exponent was -1, and then for n over here it was -1. So we have -1 over here, and of course its particular concentration, its unit is always in moles per liter or molarity, and it's big M, so we just put moles per liter. And then we just multiply it by whatever this one was. This was 0.08. Same thing, it has a to the power of -1 moles per liter. Okay, so if we put them together, you ended up just getting 0.01 times 0.08. That was 1,250. Okay, remember you have to put the exponents included in that calculation as well. So we got moles per liter, but remember we had two of these, so their exponents add up. Now we're just going to continue to write this down with our seconds, just continue to go downwards, and of course we have to eventually isolate for our K. So you just divide whatever this one was, because right now it is multiplying this thing. Okay, it is multiplying. The opposite of multiplying is divide, so we're just going to divide by this whole thing so they cancel out. So you just divide 1250 moles squared over liter squared, so that they can all cancel out really, really well. Do it on the left side as well. We'll just bring this all the way over here. Now, before I write it out, just 156 divided by 1250 gives you this value over here, okay, 0.1248. But again, we're just going to focus solely on the units, okay, not the adding with the numbers within the calculations, just for simplicity purposes. So just always remember in the back of your head that our K is 0.1248. Right now, we're just going to have a look at the units, okay? So we have seconds over here, so we're just going to put seconds, and what it's going to happen is going to divide, right? It's going to divide what? It's going to divide this mole squared over liter squared. So I'm just going to write it that way, moles squared over the liter squared, and this is also equal to K, okay? So I'm just going to keep this one over here. We're just keeping our variables and our units, not the actual numerical values. So now we can just change this up so this looks a little bit more neat. So rather than having seconds divided over here, I'm just going to put it divided left to right, so then our moles squared goes on the right side. Okay, now I could change this into a multiplication so that this flips around, but remember in the previous example we had our seconds over here to be s to the -1. Okay, so in order for that to happen, that 1 over here, because technically everything's over 1, this 1 needs to be in the numerator. Okay, so I'm actually going to be flipping it that way. I'm going to flip it so that I'm changing it this fraction and keeping this fraction the way it is. I'm just going to change it to a multiplication, so this s over 1 becomes 1 over s, and then this stays the way it is. Now what are we going to do? Well, this here is the same as s to the -1. This here stays the way it is. I'll just put a little dot there to multiply. So we have moles squared over liters squared. This here is our unit. And remember what our K value was. It was 0.1248. So I'll just put therefore this is 0.1248. And then we just put s to the -1 and moles squared over liter squared. That's it. Now we're going to be looking at the rate. Okay, we found rate in the previous question, the last video over here. We found it out to be 312 seconds. Now, how do we get the seconds? Obviously, our rate has to be in seconds, right? Time in seconds, it's written over here. However, what happened to the units over here that we're able to cancel out in a perfectly well manner so that we ended up just getting seconds here cleanly at the end? Well, I'm going to show you. Now, we did look over here just prior that our s flipped, right? And we flipped it so it became s to the -1, and then we got moles squared over liters squared, right? We abbreviated it this way, right? It's s to the -1 and then multiplied by our moles squared over liters squared. Okay, but we're not going to end up doing it this way. Okay, we're actually going to change it so that our s to the -1 does not happen, and we're just left with our s. Why? Again, because we have s at the very end here. We want to keep it as s, not change it to s -1. Okay, so we want to keep s the way it is, meaning if we multiply this, we're now going to flip this, okay, rather than the s flipping. So I'm just going to write it out over here. We have our s, going to multiply it by our liters squared over mole squared is going to be equal to K. Now, we're going to change our values here, so we're going to write it all in. Okay, I know we usually just look at our units first, okay, but I think we can just put it all together here. It's no big deal. Okay, we're going to add on our numerical values as well. So we have rate is equal to our 0.1248. Okay, this here is obviously our K. Okay, and again, this is the unit for the K. Okay, so we're just going to write it out as such. We have S over here times liters squared over moles squared. Okay, now again, all of this here is going to be in brackets so that we can multiply with our next ones over here. Again, this time we're going to have to be putting our units appropriately so we can figure out how to cancel them out. Okay, so we have our 0.02 over here. Our 0.02 here multiplies, sorry, 0.02 here to the -1 multiplies our 0.02 here to the -1. Okay, it's obviously going to give us 2,500. Okay, but remember, this here was in moles per liter, so maybe I'll write that in here, moles per liter. Okay, and this one here was also in moles per liter, so if we multiply them, we still end up getting our 2,500, but our moles and moles here gives us mole squared. Sorry, that looks like a 2,600, so 2,500. Okay, and this gives us our moles squared, and then these liters gives us liter squared. There we go. So let's bring this up here. So obviously you can see where this is going. This here cancels out perfectly with this one because they are diagonal. Okay, these fractions are multiplying each other. They're diagonal, so they cancel out perfectly. These here cancels out perfectly as well. So we're just going to be ending up with our seconds. Okay, so we'll just write this out cleanly, finish this off. So our rate is equal to our this value times this value. Obviously we know what the answer is. It's 312, so we'll just write it out the way it is. And of course our seconds is the only one that's left. That's how we ended up getting it.